In today's video, we're going to be talking about biomass. Biomass is energy produced from materials from dead plants and animals. For example, take things like deposits of animals and the wood from trees. So biomass is typically something like a renewable source. However, biomass is not completely a renewable source because it's not unlimited. Because of deforestation and animals going extinct recently, we are seeing the less production of biomass. So biomass is basically where the materials from dead animals and plants are burned up to create energy. So let's talk about how the energy is burned so that it could power our homes and electricity. So let's say we take all the dead parts like the wood, the deposits, all the dead animals and stuff like that. We take it all in one big pile and we light it on fire. On top of the fire, we'll host a tub of water. The heat from the fire that is burning the dead material will then heat the water. The water creates a steam. When it generates steam, it is turning a turbine on top of the water. Now because it's turning a turbine, the turbine's making rotational energy. The rotational energy of the turbine is going into a generator, which turns the rotational energy into electrical energy, used to power our homes and to help ourselves. Another way a biofuel can be made is from methane. Okay, so let's look deep inside the earth. So if we take a landfill, these people, they dig a really big hole. This hole, they start filling in all the trash. Here, garbage would be considered biomass. So basically, the decomposers eat the garbage. However, there's no oxygen below at the bottom of the landfill. Because of that, they breathe in CO2. After eating all the trash, methane is released. So what happens is that they actually drill this part where they can capture the methane. When they capture the methane, they burn it. Then they burn the methane, which is then used as a fuel to heat up the water, and that makes steam. That turns the turbine, the rotational energy of the turbine. The generator turns the rotational energy of the turbine to electrical energy, and that's sent to the national grid, etc. Yeah. So that's how methane can be used to produce biomass energy, so that we could have electricity in our houses and heat up our homes. Methane is actually way more harmful than actual carbon dioxide itself. The reason why is because of the greenhouse effect. So because we're sending too much methane into the atmosphere, it's making our days much more hotter. So because of that, this is bad for Earth's climate environment. So we should not really do this that much often. We should be pretty mindful on this type of biomass energy. The last way we can produce biomass energy is through biofuels. So there are two ways. There are two biofuels. One is ethanol and the other is biodiesel. Ethanol is let's take corn and sugarcane. This can be converted into ethanol. Ethanol is pretty similar to oil, so it can help run our cars. And we don't have to use resources from underground. Another biofuel is biodiesel. This comes from vegetable oil and animal fat oil. We use this oil, which is also similar to regular oil, and that can power our cars and buses. So this is a much more natural way of making oil than having to go down and dig for it. So these are different ways you can produce biomass energy. Let's move on to the history of biomass. Ever since man could hold fire, we pretty much have been using biomass in different ways, but we never knew it. For example, take your fireplace. Your fireplace consists of woods. We take a fire and burn the wood to heat our house and our living room. Because of that, that is one way that we use biomass. There are many other ways we use biomass, but we just don't see it. So we're going to be doing the second and third way we produce biomass energy. And if you're wondering what those are, for the second one it would be methane gas, and the third one it would be ethanol or biofuels. So let's move on to our demonstration. All right, so now we're going to be doing an experiment on ethanol and the biodiesel. But we're only going to do ethanol. So over here we have yeast, sugar, and warm water. Here's what we're going to be doing. So yeast is an inactive microorganism. So basically this yeast, we're going to pour it in this bottle. So their yeast are not inactive, so it really won't do anything. All right, we got 1 tablespoon of that.
And now we're gonna pour the sugar.
Idan's gonna pour 1 tablespoon. Idan's put too much sugar.
My favorite.
All right, so we poured 1 tablespoon of sugar. So basically, the yeast is inactive, and the sugar is going to act like the food. However, yeast is right now not going to eat it. But first, if we wanted to eat it, we have to pour water, which will turn the yeast active. We have to pour warm water to make this work, okay? So I don't pour carefully. That's it. All right, so now the yeast is actually active. Okay, first we'll shake it, and we're gonna explain while shaking it. All right, so basically, here's what's going on, okay? So the warm water, when it touches the yeast turns from inactive to active. When the yeast turns from inactive to active, it uses the sugar and starts eating it. This creates carbon dioxide and ethanol. So basically, the ethanol is what we use for gas. Right now, you cannot see the ethanol because it's mixed with the water. So basically, you tie a balloon on top of this. We tie the balloon on top of this, so the carbon dioxide can fill up this balloon. It'll take at least 20 minutes for the balloon to fill up properly, and with that, we'll be able to capture carbon dioxide. So you see the carbon dioxide, it filled this balloon. It filled a lot, so it's kind of impressive, to be honest. And if you didn't know, the tints again mixed with the water. So in the second example, we explained how methane can be used to create biomass energy. So now we're going to be demonstrating that. We have these blueberry and onion scraps. They weigh the same on this weight, as you can see, 125. You can see over here, they weigh 125 grams for the blueberry. And for the onions, we have, again, 125. So they weigh the same. The reason why we're weighing them the same is so that we can see which food scrape can produce more methane. Is it the blueberry or the onion? So let's look at this demo. We're gonna pour this onion scraps and the blueberry scraps in this.
I'll put a blueberry and then we'll pour the onions.
So we're not fermenting it like the last one, we're gonna actually decompose it. So it's this and regular water. We already put the scraps, like the blueberry and onion scraps in this. Now we're gonna put regular water and we're gonna pour it inside each bottle, all the way till the neck. So let's do it. There, that's the neck. And we'll come over here. Alright, so our water is done. Next, what we're gonna do is, we're gonna put a balloon around the cap over here because we don't want any oxygen to come in. It's because we're trying to produce methane, and the onion scraps you can see over here, whenever the decomposers are trying to decompose the onion scraps, basically it's producing methane, and we don't want the methane to also escape. And so we don't ruin the process, we're not allowing any oxygen inside of it. And the carbon dioxide is going to be trapped inside over here. All right, so we see those two over there. We're just going to leave it for the next 2 or 3 days, and we're going to come back. So wish us good luck.